Well, good morning and good afternoon to everyone. Thanks for joining us today for our first in a great series we are calling the DevSecOps Bunch for 2021. I'm super excited to have friend and partner Jeff Williams, co-founder and legend in the application security world from Contrast Security. We're going to be talking about accelerating DevOps with autonomous security and observability as a core part of our conversation. I've got a few points to get us going here before we get rolling. We will be recording this webinar and you will receive a link next week to that recording. We will be taking live Q&A at the end. Please ask questions using the Q&A tab in your Zoom navigation on the bottom of the screen. We'll collect those and we'll answer those questions at the end. We also have an open chat on this webinar, so it's configured so all audience members can chat with each other. And we have some moderators from Contrast and NowSecure in the chat as well that will be helping answer and guide within the chat itself. And then finally, be sure to stay at the end. We've got some cool giveaways. We asked some fun questions at the end and some cool giveaways for you. So please hang around. We'd love to send you some stuff because everybody likes stuff as part of participating today. So quick look at our agenda. So we'll be covering introductions here in a second. We'll dig into state of mobile AppSec. Contrast and NowSecure have been collecting data for nearly a decade that we're going to share. And what we've collectively realized is there's a better way to do security testing, and it's inside out. And we're going to talk about it today, and you'll see how it's a proven approach that really is the most cost-effective and lowest friction way to get there. We've got some resources and references for you for further learning, and of course, open Q&A. So I'd love to ask you, Jeff, to introduce yourself, and then I'll complete my own introduction and we'll get rolling. You're muted.
Man, such an amateur. Thanks, Brian. It's nice to be here. Thanks, everybody, for coming. My name is Jeff Williams. I'm the CTO and co-founder at Contrast Security, and I've been working in application security for about 20 years. Along the way, I helped to start OWASP. I was the global chair there for 10 years. I ran a consulting company for many years, and I've started application security programs at quite a lot of very large organizations. And then I had the chance to start a product company with Contrast, and we'll talk a little bit more about that in a second.
Thanks, Jeff. And so for those of you who haven't met me before, I'm Brian Reed. I'm the Chief Mobility Officer here at NowSecure. You might wonder what Chief Mobility Officers do. I've been doing mobile for over 15 years, dating back to BlackBerry, which was really the first generation mobile. And believe it or not, going all the way back to like compact iPads back in the 90s. So I live the mobile world. I spend a lot of time with our customers on strategy, digital transformation, mobile innovation, things of that nature. And I spend a lot of time talking at events and sharing knowledge and information like I'm going to be doing today. So I'll act a little bit as moderator, but we're really going to tag team as we go through. So a quick introduction to NowSecure. For those of you who are not familiar with us, we've been in business for about 10 years. We were founded at the birth of the iPhone and Android devices back in 08 and 09. And over that period of time, we built out a mobile forensics practice that moved into mobile pen testing and eventually mobile commercial software delivery. As with Jeff and his work with OWASP from the web side, we've been involved with OWASP from the mobile side since the beginning and contribute heavily to the OWASP mobile project. We'll talk about some of that today, along with open source tooling like Frida and Radari. Work with lots of different organizations of all different sizes, obviously. And so we really bring a unique combination of automated security testing software that we're going to talk about, as well as expert pen testing and training services so organizations can holistically build the best mobile AppSec program they can. So, Jeff?
Yeah, thanks. I really think that Frida project is amazing. I love companies that build open source projects and also contribute back to the community. So Contrast is a product company. We work in web application and API security, and we offer a pretty complete platform. In addition to finding vulnerabilities, Contrast also analyzes open source for known vulnerabilities and unknown vulnerabilities. And we also offer protection for applications in production. We've got partnerships with both Microsoft and AWS. Microsoft invested in Contrast, and so we're very tightly tied into Azure DevOps pipeline and so on. And well, as you can see here, we're Gartner Application Security Testing Visionary. have been for quite a while, and we're also the #1 Peer Insights customer choice product in the AST market. And you can see there's a list of languages that we support down at the bottom. So if you're writing code in any of those, we can probably help.
Excellent. So what we'd like to do is we have 2 quick polls to launch here at the front end. If Kelly can assist me with the polls, if you want to bring the first one up. And the polls really are, to learn about your role. So Jeff and I, as we talk, understand kind of who's here today and what topics you're most interested in, and we share our stories effectively. So whether you're dev or more on the DevOps tooling side, whether you're in security, QA, executive leadership, what have you, I realize you could be an executive leader in any one of these departments. Pick your favorite poison. We'll leave the poll open. We've got about half of you have voted so far, so if we can get a few more folks to vote, and then we will end the poll and have a look at the results. Looks like it's stabilized. Are you able to show? There we go. All right. So we're at about biggest crowd here. Almost half are in security. We've got about a quarter folks are dev, about 20% are on the DevOps side as well. Handful of executives and QA folks. We're glad to have you here. We're going to talk a balanced dev security conversation, really about helping you speed your DevSecOps. So if you want to end the poll, Kelly, we'll go ahead and get rolling on the second poll. And so really the second poll is about, where are you in your journey? In poll 2, let's have a look at where are you in your journey? Are you waterfall? Are you agile? Are you DevOps? Are you all the way at the DevSecOps sort of maturity level? I realize there's variations on that journey as well. We have a lot of security people, a number of dev and DevOps people here as well. Obviously, you're going down the path. What we tend to find is the bulk of folks tend to be around agile or DevOps, kind of moving into DevSecOps. And so I'll leave it about 5 more seconds if folks would like to get their answer in. Looks like we have a little over half the group has voted so far as well. And so as I look at kind of the summary of where we are, looks like we're kind of tied between agile and DevOps. And then there's a good 27% of folks that are already in DevSecOps phase. Gotta love it. We appreciate all of you joining. I think there'll be something for you, no matter what stage you're in. And in many instances, you may be in a more mature stage, but looking for a better way to do it because you're realizing it's still hard to use traditional methods and approaches and so on and so forth. Hey, Brian, so if you want to end the poll, Kelly, Jeff, go ahead.
I was just going to say, do you find that companies are in a lot of multiple states? I mean, most of the companies I work with have, hundreds or thousands of software projects, and some of them are super advanced, and other ones are, legacy projects that really aren't there. And so I think most organizations are in multiple stages of maturity.
Yeah, I think the bigger the organization, the more likely there is to be diversity of teams, right? And are you working on a legacy digital transformation project that's got boat anchor mainframe infrastructure sitting behind it that's 30, 40, 50 years old?
Right.
Are you pure play building a new from the ground up system where you want to use all the modern tech stack, your cloud and Kubernetes and so on and so forth, right? There's different places that even individual teams can be in, right? And so you make a really good point that there isn't one size that fits. I'm sorry?
I like how nobody admitted to being a waterfall project.
No, non-waterfall.
We
absolutely appreciate. Yep. All right. So if we want to close up the polls, Kelly, I'm going to go ahead and get us started here. So, when we look at mobile, it's interesting. Jeff and I have been around application security for nigh on a decade, and it's kind of gone through this great growth in terms of investment and strategy and prioritization. And so what's fascinating about it is, if you sort of look at the AppSec spend growing from sort of 2.2 billion in software spent to 3.2 billion, estimated as a close for last year, and growing another 10% or so to 2024 year over year. The reality is we're throwing a lot of dollars and resource at this, yet we still have sort of very low success rates for many kinds of organizations. And so there's this interesting economic mismatch of it's great that the prioritization is growing and investments are growing, but it's not necessarily correlating with the outcome for every organization. Many are achieving great goals in terms of improving security and velocity, but a lot are spending a lot and kind of treading water. And both of our organizations have kind of looked at this and said, hey, there's a different way to do this that might be better. And so, statistically, treading water in that stack, right? The mobile application security market is estimated to be about 300 to 400 million of that 3.2 billion in 2020. When we benchmark apps, we're benchmarking continuously analyzing the millions of apps in iTunes and Google Play. In terms of the public app stores, we find 85% of apps still have security risks. They fail one or more of the OWASP top 10. 70% leak data that would violate GDPR or CCPA. And a really, really low number of organizations are actually able to automate most of their test cases. And that leaves you to the world where mobile is flying really fast, but security is often left behind, and that creates some challenges. Jeff, what's going on in web?
Well, it's a little disheartening. I wrote the OWASP top 10 in 2002, and if you look at what's in there today, it's roughly the same stuff. So unfortunately, we're not making a lot of progress. It goes exactly to your point. We're spending more money, but we're not really advancing the state of the art in application security very well. The stats are similar. We analyze many tens of thousands of applications, continuously monitoring them, and we see almost all of them have at least one vulnerability. It averages about 35 vulnerabilities per app, actually, which is kind of crazy. If we were building airplanes, nobody would fly.
No good.
There's a lot of problems with open source libraries. That's a big chunk of those vulnerabilities. And on the attack side, which is something that not a lot of people get good data on, 13,000 application layer attacks per month, per app. That's a lot. And most organizations are kind of blind to that traffic. I think it's interesting. The number of applications that wasn't attacked last month, 0. Every month, 0. Everyone gets attacked all the time.
Yeah, I think that's real. The practical reality is attacks are continuous, right? There is sort of no safe space. And when you look at something like a mobile architecture, for example, that thing's running in the wild. You mentioned Frida earlier. Great way to reverse engineer your mobile app and figure out what's going on. Great way to reverse engineer what's going on the back end.
Yep.
And so when we kind of think about what does your sort of dev plus sec plus ops look like, we tend to find kind of, 3 patterns, right? The first one is the dark ages, lots of manual labor on the production line, throw bodies at it, et cetera, et cetera, et cetera. Then you get the kind of steamroller where basically development says, we'll see you later, security. We're just going to ram this stuff out the door and hopefully you can keep up. And then the only way to solve that gets into automation, the scale and volume of code being written, the velocity with which it's moving through pipelines. We're at the point where humans can't keep up. And so automation becomes the key, but it's also, are you automating the right things? And that's some of what we're going to talk about today, is how to bring that right mix and think about the problem in a different way.
It's funny, I think where development teams have progressed farther down this path towards automation, many security teams haven't. So even if you're using scanner kinds of tools and web app firewall kinds of tools, there's still an awful lot of dark ages, human expert kind of work in those kinds of programs, even if the development teams are super high functioning DevOps organizations.
Yeah, I mean, you could see developer teams that are working at a really fast velocity, and the tooling is doing a lot of the grunt work for them, right, to make them efficient in doing that. And so, oh my, lots of attack patterns. I'll hit the front end, you get the back end, right? So we were sort of like, well, how many do we want to list? And there's like hundreds of them. And what we tend to find mostly in bulk on the front end is that because the mobile app's running on a device in the wild and because it's reversible, basically any reasonable attacker can easily reverse engineer, run the app, and figure out what's going on. And so we find a high rate of things like man-in-the-middle attacks because of improper cert validation, improper network configuration, et cetera, et cetera, et cetera. Google and Apple in their APIs actually created a pair of secure APIs for connecting the client app to the back end. 60, 70, 80% of the applications we look at don't use those. They use something else, an open source library or whatever. So like the built-in security sometimes is bypassed. There's a ton of sensitive data leaking on the device, over the air, kind of wherever you go. And there's all interesting things that can happen because now you've got possession of the device. Like, can you spoof a GPS so you can move somebody to a different place to allow access to data where maybe they're using geofencing and other types of side channel attacks. So the front end is kind of the Wild West in terms of exposure, and all that code is exploitable. And then you have the back end. Tell us about the back end, Jeff, and the server side.
Yeah, well, I mean, there shouldn't be any surprises here. The attacks on the back end are the same kinds of attacks we've been wrestling with for, over a decade. We still see pretty massive amounts of SQL injection. Command injection and expression language injection are both interesting. They allow you to completely take over the server. Expression language injection in particular is interesting because it's the kind of breach that caused the Equifax problem. And we're still seeing lots of new expression language injection vulnerabilities in apps, both commercial products as well as homegrown web applications. And there's some things that I think are more automatable at the sort of the top of this list. And then there's things that are really much more difficult to validate automatically, things like broken authentication and broken authorization, which are mostly custom per web application and web API. So I think my perception is it's still a pretty complicated problem for organizations to go tackle. There's plenty of work.
Plenty of challenges, right? And that kind of gets to almost the ghost in the machine of how are you going to build your infrastructure in order to cover it. So, if we look at kind of enumerating these challenges, right? Some of you may be listening to this already. So SaaS source code scanning, it's not a bad thing, just an incomplete thing. Lots of noise, misses, especially in mobile. It misses about 90% of the real world vulnerabilities, that we have. When we wind up working with an organization, they're like, but we're using SAST over here. And we're like, well, here's this whole stack of stuff you missed. Because it doesn't find it, right? The outside in DAST, the challenge with that in many instances is the manual complexity. That's why a lot of teams turn to like a pen testing approach where they use security analysts to do the work, but you can't stick a security analyst in a pipeline and say, go do a pen test in 15 minutes in a build cycle, right? So open source is everywhere. I know, Jeff, your team has expanded dramatically around covering open source because it is, and we're doing the same. And all of these things basically lead to a world where you need lots of people, lots of manual activity. And, as Jeff said earlier, well put, the dev team is automated, the security team largely isn't. And the automation that they have isn't covering the key areas of risk and exposure that are the challenge. And so, both of our organizations looked at this and said, let's try this a different way. How do you bring automation and efficiency into the program while actually increasing the security hygiene? I was just going to
say quickly, one thing I found with this is, most organizations have some kind of SLA around their pipeline, and it might be 15 minutes to create a build and deploy. These scans, SAST and DAST scans, can take hours. We did a survey recently that showed on average they take like 5 hours to run a scan, whether it's SAST or DAST. And there's no room for a 5-hour scan in a 15-minute pipeline. It might be automated sort of, but it's still a lot of manual work, but it just doesn't fit. And I think that's the friction that we're focused on here, is there's just an incompatibility between old school tools and the way people want to build software today.
Yeah, I mean, you're great teeing up this picture, right? We've all got some diagram of whatever our dev process is, right? And the reality is, for a lot of organizations, they're trying to get to, commit to deploy in minutes to hours, right? Or they're trying to get to iterative daily work that moves the needle. And, they're coding all day. They want to run a build test cycle for an hour at night and start over again. We have customers that are doing follow the sun. So you've got people all around the world doing basically continuous development all the time, right? On code stacks at organizations like Uber, for example. And so we'll use this diagram kind of to talk about, well, how do we work our way through gaining efficiency at every point, right? And so a lot of this is about reimagining the approach, but in a proven way, because our two companies have been doing it for 10 years. To get you to think about, consider, the typical pipeline and where you can take it. So, a better way we see together is what we call security from within. And it's really two parts. The first part is embed security instrumentation into the apps themselves that you're building and testing, right? You can do outside in testing, and there's the challenges of that. But what if you're actually inspecting inside, in our world like Frida Radare, in order to do that work? That's the first part. And then the second part is embedding that testing activity and sensors into the toolchain itself so that it can activate and collect that telemetry kind of through the process. And kudos to Jeff. He's the first guy I saw figure it out. We in parallel a few years later got there. Jeff, how has this been in changing the journey? How is this improving things?
Well, I think the big advantage, well, there's two big advantages, and we'll dive a little deeper into this, but embedding the instrumentation into the applications itself gives you much better visibility into what's going on inside the code. Instead of just looking at the HTTP traffic or the source code, which gives you sort of a weird abstraction of what the application actually does, instead you can watch it while it's actually running. So you can see the transactions and all the security relevant activity that's part of it. And then the second part is by embedding it into the pipeline and just making it part of the normal test process, it works in real time. So, that means you don't have to disrupt the way that you build, test, and deploy your code. Security can really be just part of normal development. Those are the kind of the two big advantages. And I think the top bullet here is really important. Anyone can do security testing with this technique. So let me just take a second and explain instrumentation. So the idea here is instrumentation, whether it's in the mobile app or in the server side backend. What we do is, as the application starts up, we add tiny sensors inside the application so that they're part of the application as it runs. And this is exactly the same technique that performance companies like App Dynamics and New Relic use to get performance information, but we're using it for security here. So then once it's instrumented, you just use your applications the normal way. You build code, you test it locally, you do automated tests, you put in a CI/CD pipeline. Those sensors are there watching everything. And whenever they see a pattern of behavior that represents a vulnerability, that vulnerability gets instantly reported to the people that need to see it, with all the context and the details down to every line of code. And there's a huge accuracy advantage here because we're sort of directly measuring the running application. So when instrumentation reports a vulnerability, it's because it watched it happen and it has all the details of that. Yeah. I think that's accuracy is like the huge benefit here, but there's also some benefits in terms of speed and scalability because you get this instant feedback and you can run it across hundreds or thousands of applications in parallel, as opposed to having to try to scan each application serially.
Yeah, absolutely. And I think what we'll do is we'll have a look at what does this kind of look like practically in a web app world and a mobile app world. And as I step into sort of looking at it from the mobile, and then I'll hand it back to Jeff for web. We think about mobile apps are really two parts, right? So you got the binary code that's going to run on your device, and then you've got the back end, right? And all mobile apps talk to some sort of APIs on the back end, whether there's commercial services or the business back end. Now, what we find with many customers, if not most customers, is that back end is basically the same back end that is running the website and other resources, right? You stand up an API-driven backend infrastructure as a common set of shared services, and then your mobile apps, your web apps, and whatever else you're building, thick client, even if you need it, will access those services. And so we're making the assumption that in the mobile world, you're using something like Contrast to make sure you're scanning the back end. So what we really need to do is look at that last mile between the back end and the front end, but also interrogating any APIs that aren't standard APIs that might have been covered in your standardized testing. Now, the mobile world's kind of intriguing because when you think about it, there's lots of different development environments and languages on the front end, but the best way to actually test an app is in its binary stage, right? As Jeff said before, 5 hours of scanning, you get only 20% code coverage. And mobile, you really need the binary to run, and you run that binary, and then you can really see what it actually does. What third-party libraries does it use? Mobile apps are full of things like third-party instrumentation APIs, third-party services networks, a ton of ad libraries and things like that. So the data is fragmenting. We find the average mobile application might be talking to dozens to 100 APIs on the back end. Maybe using Facebook shared login and so forth.
I think that's a really excellent point, and people should know modern applications, whether they're in the phone or on the back end, they really only ever come together at runtime when they're all put together. Right. Lots of web environments, the libraries are dynamically loaded. It might be a different library that loads depending on what app server you run it on. It might have dynamic code that loads from a remote source. You can't really just look at a code repo and say you've analyzed everything.
Yeah, and that's why we have this conundrum of there's all these vulnerabilities, but I'm doing SAST because DAST is too hard, right? And you have this pickle problem. And so when you run that real app and so forth, then you want to make sure that while you're monitoring the app, you're making sure you're checking against standards, right? So using OWASP SIM ASVS as a standard. For those of you in federal, you might be using NIAP as a standard. There's other emerging standards in various tech stacks, and even just using things like mapping back to CVSS to define the risk of the particular app and so on and so forth. And so while you're running this now, you actually get it's running like an attacker would run it, right? So they can see it, and the same kind of instrumentation an attacker would have, you've got built in here and throwing off into the sensors automatically in your pipeline what's actually going on. So when you build an app and then you go into your test phase for QA, and then automatically the security testing occurs during the test phase and then feeds back tickets back into the infrastructure, right? Which is an ideal kind of world. No security analyst has to review anything. It just automatically gets fed back to the developer. Now, when you think about mobile apps as compared to a website, there's also this thing, if you're publishing it, called Google and Apple. And those guys have their own rules and regulations about what's an approvable app or not. And so while you're running the app looking for security vulnerabilities, you should also be looking at, are there any things that are going to prevent me from moving into the app store? Right. And there's a variety of those using extraneous APIs that are unapproved by Apple is a great example of people getting bounced. Apple today now has privacy issues that you need to make sure you address and so on and so forth. And then the last part of this, and this is just best practices for those of you doing mobile, is remember I said how easy it is to reverse engineer those apps? Try to instrument, somehow inject obfuscation and hardening of that binary as a best practice as well. That's a big thing in the MASVS as to whether your app requires app hardening and you should implement app hardening or not. So think about how that fits in and where that fits in the cycle. And so with that, Jeff, I'm going to hand it to you to talk about the web side of this in the back end.
Yeah. So the good news is we went one too far. Yeah, this picture is almost the same. And we called this autonomous security observability for a reason. So autonomous is understandable. That means we're doing this without any manual parts. This is happening automatically. But the security observability part, I think, is important. Observability is about making the inner workings of something exposed to the outside world. And so what we're doing here is we're adding this agent which watches the security behavior and then makes it observable. Once it's observable, then you can measure it, you can change it, you can fix it, you can improve it. But unless it's observable, you don't have a chance at doing that. So that's the key to this technique, is making security observable. In fact, interesting side note, when we founded OWASP, we made the mission of the OWASP organization to make application security visible so that people can make informed decisions about risks. And it's really important, both at the macro level and within each application, to really get that visibility. So using this instrumentation approach, you can make security within your web apps and your web APIs. Actually, APIs are really important. Most modern apps are mostly APIs on the server side. You can make them observable. And all you have to do is add this language-specific agent to your application environments. You test your application normally. You don't have to be an expert. and then you'll get notified. So I'll give you a SQL injection example because it's pretty common. So let's imagine that you've built a server side for your mobile app, and you've got some queries that go to the database. The attacker might use a tool like Frida to reverse engineer the mobile app. They might start sending their own traffic to your web API, and they might start tampering with that traffic to try to break your server side and and steal everyone's data. So with this instrumentation technique, it's like having a friend on the inside of the application. You don't have to attack your application. You can just use it normally. And this agent with the instrumentation will watch the data from your test cases as it flows through the server side. And if untrusted data from your tester case or from your tester reaches a SQL query without being properly escaped or parameterized, the instrumentation will flag that behavior and report it out with all the details, the exact line of code and everything. This is really quite different because you can find vulnerabilities without having to exploit them. That means anybody can do it. And so the big so what here is if you empower development teams to do their own application security testing as part of their normal test cases, their normal pipeline, they can fix their own problems, check in clean code. We can reduce massively the amount of work that the security experts have to do. We can get them out of the critical path, and we can push code into production faster. We can accelerate the delivery of value to customers, which is really the whole point of IT in the first place. So that's the big picture here on how this kind of all fits together.
So as we think about the yin and yang of testing the front end and back end, we also have the production scenarios. So Jeff, talk about what happens at runtime.
Yeah, so this is kind of a bonus. You can also use instrumentation to get that autonomous observability and even protection in production. And so this is often referred to as runtime application self-protection, or RASP. And you remember the beginning, I said applications are attacked 13,000 times each month. Well, the same instrumentation that we use to detect vulnerabilities, we can use those to detect attacks, create that observability from production, and even prevent those vulnerabilities from being exploited. So here's how this works. It's the same agent, the same sensors now are in production. And instead of watching test data flow through the app, they're watching real traffic flow through the app. And if they see behavior that represents an attack, they can intervene and prevent that attack from successfully exploiting that vulnerability. So that SQL injection example I gave you, imagine an attacker tries to exploit it. Instead of trying to block it at the perimeter, which is really difficult because maybe our mobile app is using JSON or XML or serialized objects to communicate with the server-side APIs, defending the perimeter is really difficult when you're using complex protocols and data formats. So RASP works differently. RASP watches that data go through the application, sees how the application is using it. It would track it all the way into the query. And if that data changed the meaning of the query, that's when it would intervene and prevent that query from going to the database, because the attacker should never be able to change the meaning of a SQL query. So this is really powerful. It works on vulnerabilities in your code. It also works on vulnerabilities in libraries and frameworks that you're using, even the app server yourself. So you're protected when a new vulnerability comes out. And our customers, when Equifax got breached, they all asked like, hey, are we protected? We said, yep, absolutely. We cover expression language injection. We prevent it from being exploited. And so they could comfortably take their time, go fix that vulnerability by updating the libraries. They had insight into who was attacking them and which attack vectors were being used and what systems were being targeted. And so they had that confidence they need. So you should absolutely add RASP to your application stack, whether you're hosted in a data center, cloud, container, or wherever else. It's a really easy way to get both visibility and protection. And the one unique kind of benefit, I think, is when you get that kind of observability, you can really help create a culture of security. You can take that threat intelligence feed it back into your development processes, and get developers aware that, hey, your code's being attacked in production. We should fix these vulnerabilities. So it changes the game. Brian, tell us about let's zoom all the way out and then show the big picture when you put it all together.
Yep, and that's kind of where we're going, right? So as we tie this all together, right, what we're really talking about instrumenting the app and instrumenting the pipeline all the way through deployment into production, right? And that's where value comes out the other end. And so if you just take a step back and say, okay, today I'm running 5-hour source code scans, covers 20% of the code. I've got something else that's looking in my open source repo just to see what's being pulled into the repo. I've got a pen testing team over here. I've got a team who's reviewing security analytics and security output and determining what bugs to fix and feeding it into tickets and, ching, 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 lots of labor, lots of slowdown, lots of friction. What's basically happening now is it's a no human necessary autonomous operation that we've been talking about because of that instrumentation being embedded in the apps and in the pipeline. And so that frees up everything else, right? If you think about it, it's like a continuous home monitoring on your house. Once it's there, it's always working. It's very highly accurate because it's actually experiencing real events that are actually happening and catching that, and therefore giving you mini POC basically as a result set. And it runs quickly, however fast you want to. It just runs in the background, right? So it's a function of how long does your running the app take? How long does your QA script take? Or what have you to run your security in parallel, and why not run security at the same time? Why make security be a different step in the process? Take out all that labor, take out all that friction. It's highly cost effective. Our products cost money, but they're not outrageously expensive. For the less than a cost of a single pen test, you could be testing 2 apps with my software. So the economics are tremendous when it comes through to building it into the infrastructure and the economies of scale we bring. So now when you talk to our customers, they say we get the scale and the velocity we need because security is just baked in the background. It's just there. It's just doing its thing. Jeff, what do you want to add here?
Well, I just want to say one other way that we've seen our customers scale with this is instead of building the instrumentation into every application, they build it into the app server platform, their standard one. So, if they're deploying either with a gold image of a server or via a container, like maybe they've got a Docker container that they use as their standard server, or Kubernetes, or however they deploy cloud, we put the instrumentation there, and then Contrast is just there automatically. Every time you run an application, Contrast is just there in the background. It starts doing its job, and it's almost completely frictionless. We've deployed to thousands of applications in under a year using this technique.
Yeah, I think both of our customers have seen a great gain. Sorry, I'm clicking and waiting for it to do its thing. There we go. So you tell us a story about yours and I'll do mine.
Yeah, so this is one example of a large company that we worked with. This is a Fortune 100 insurance company, and they were struggling with application security. They were spending millions on it, and they really weren't seeing the value. In fact, their CIO pulled me aside and said, Jeff, security is an impedance to us. It adds story points to every single thing that we try to build. And so we looked at it, we came in and we used exactly the technique I described. We got Contrast into their standard application platform for most of the apps. We deployed to 750 applications very quickly. And we found quite a lot of vulnerabilities, but that's not a great measure to me of whether your AppSec program is working. What you want to do is get better at writing secure code over time. And so we measure mean time to remediate as a really good way of measuring how well you're able to shift left. So here you can see this blue line is the sort of the average for static analysis tools. You can see it takes 4 months to get to 50% remediation of vulnerabilities. We were able to reduce it down for this customer to 8 days to get to 50% remediation. So there's this huge, risk gap that we closed for them. And actually, as we go forward, what we see with customers is this gap gets even better. we also looked at their open source. They've been successful in moving most of their libraries pretty far left here, so that most of their libraries are less than a year old. They've got 17% of the industry average of libraries that have known vulnerabilities in them. So we've been successful at really helping them monitor this and get in front of this problem. And then, of course, there's attacks in production, and they did not have good visibility into who was attacking them and what attack vectors they were using. So we identified a lot of attacks for them and created that observability. We also blocked a number of attacks that would have successfully compromised their applications, but for Contrast being there. So, this is on this insurance company's main websites. Their most prominent business is relying on Contrast for protection, both in development and in production.
So I'll tell a little mobile story here as well. Let me get it to click onto the next slide. When we look at this, we find that the customers all tend to collapse into a similar pattern of gain. So for a lot of this, it's about fast feedback loops. An example would be with our one of our newer clients, Caribou Coffee, right? They're a competitor to Starbucks and the other guys. And Caribou had slow pipelines, slow feedback, manual testing, all the challenges, right? Within 90 days, 120 days, their release cycle went from quarterly to monthly. And they're going to try to get, into an agile 2-week type of scenario because of the faster feedback loops and the improvement in coverage. There was a big triage hurdle in the front end, which was, hey, let's triage everything we can find. And then you get into steady state because you're moving from a SAST only point of view that's missing the other 80% of where vulnerabilities are to getting continuous security scanning all the time and finding those things that are often found through DAST or manual pen testing, running through all of that. And so that moves into time and again, organizations are moving from 3-month, 6-month release cycles to 1-month, 2-week or daily release cycles in order to do it. From a productivity perspective, we started out in pen testing and pen tester automation, with tools for pen testers to use to automate their work. And so a lot of our early work was with organizations collapsing a pen test from 2 to 3 weeks to 1 day. And we have tools we sell to help pen testers do that more effectively. And what wound up happening here is we looked at sort of time motion studies with a couple of our customers is the security team is not fighting the same security battle now. The productivity of the security team is now applied to interpreting things and working on education with the engineering team, not chasing bugs every day, right? And so that dramatically shifts, and that productivity boost comes back in dollars to the business overall. Universally, pretty much every customer appreciates the fact that they now have a predictability of release dates. One of the most common challenges in mobile is late stage manual testing is unpredictable. It always finds stuff, and then you got to delay the release to go fix it, or someone signs off and insecure code basically goes out the door. And so a number of our bigger customers, it's all about that predictability of release date. I know we're doing continuous security testing at whatever release pace we're doing. And I know a surprise security test result at the end is not going to blow my date, right? And that's where the economics come through, right? If you got a release date, your business probably has some revenue gains or other metrics associated with why it's investing in that mobile application in the first place, whether it's a new one or improvement. There's anticipated ROI. And if your release dates slide quarterly, you're losing a quarter's worth of ROI. So we want to enable people to be able to get there.
Yeah, that's a really good point. I think it's important that people think about the total cost of ownership of their security tools and the ROI that they can get from a better approach to security. And there's cost savings from using an instrumentation approach because it is faster. It requires less human effort. But there's also quite a lot of what I would say total value that you can get out of these tools. If you increase the velocity of development, the speed of innovation, you're going to get massive payback on your investment in these security tools by getting most of the security work out of the way and allow your pipeline to flow quickly into production.
Absolutely. And it's also like it's in the standards now. Largely what we've been talking about is IAST, and we both have a bunch of customers, and standards are now saying this is the way to go. Jeff?
Yeah, I'm really excited about this. Contrast is in use in lots of really large organizations. We're protecting, as I mentioned before, many tens of thousands of applications. And the standards groups have recognized that IAST has been around. It's proven. It's, I worked with NIST on 853. They've included both IAST and RASP requirements in it's the major government standard for secure systems engineering. And also PCI has adopted this in the latest PCI software security standards, include both IAST and RASP as well. So, this is not risky technology. This is proven stuff that's been around for quite a long time now.
Yeah, I was talking with a former CISO for one of the world's largest consumer packaged goods companies yesterday, late in the day. He's just moving on into new things. And we were talking about this, and he's like, oh, I just want embedded security controls. I want them in there. I want them able to run. I want my teams to understand them. I don't want to have to be pestering them with it. And, why don't we have more standards? He didn't realize NIST had it, or PCI or what have you. He's like, yeah, we need more of that out there to get people to recognize there's a different way. And what was interesting to him is he said, this is a straight up cost benefit analysis, right? What you're basically telling me is I can decommission some labor and tools and reallocate them to more efficient tools. And then that unleashes the labor to do other work. And the labor impact you have is not just security people, it's also the developers, right? All of which gives the business velocity. And when we look in the mobile space, two places to pay attention as we've been talking is, from a NIAP perspective, that's a really great example of an ideal profile modeling in the 52 points of coverage. And NIAP's mostly used in federal, but the MASVS is the place to go, right? Again, Jeff's been around OWASP forever. The MASVS is the evolution of the OWASP mobile top 10, and it really is the Bible now for doing it. And it's the Bible on how to build security into your apps and test it. You ought to use it in part of your testing programs as well, right? And it carries through on the coverage there. And so with that, we have, we're going to move into.
Just tack onto that. I'll just say, we've had standards for application security forever. I started the ASVS project, the Application Security Verification Standard at OWASP many years ago. And there's been requirements, but organizations haven't been successful at, getting the most important ones and, doing them 100%. And so I encourage you to focus on the things that are most critical for you. There's lots of requirements, but if you can stamp out things like SQL injection and expression language injection and SSRF and so on, you'll be making massive progress towards being more secure, and the compliance will follow. But don't build your program around achieving compliance first, because it'll be much more cost prohibitive.
Definitely be harder to get there. And I think I don't think either Jeff or I can stress enough what we're actually doing is we're talking about an easy button. This isn't climbing a hill. This is sticking instrumentation into your pipeline and your apps and letting it run and then dealing with the output, right? It's a radical change. It's not deploying new tools to your developers or try to teach them how to use something in their IDE or whatever else. And by running passively, that's how you get a lot of the performance gains that we're ultimately talking about. Now we're going to move into Q&A here in a second. Both of us have some free resources here. So in order to keep the ball moving, I'm just going to mention that these resources are here. You'll get a copy of the deck, both NowSecure and Contrast both. We have, I guess there's a build on this. We have, we both have a big collection of content for you. I think the Security Observability report is awesome. Get a look at that. If you haven't looked at the DevOps community survey, that many of us participate in, have a look at that. There's some great stats in it for you to use. And we encourage you to take advantage of these. And of course, we're available for follow-up conversations with anybody. Jeff, anything to share before we get into?
I was going to say, slide a copy of the AppSec guide for the new hired CISO to your CISO, to your exec security folks. Many CISOs have sort of a network security background and may not have a really good handle on application security and development and DevSecOps and all that. So this is a good way for them to get up and running.
Absolutely, it's a good point. We have a building a mobile AppSec program guide peer type of content as well. If you're new to this and trying to figure out, in many instances, we're plugging into teams that are web experienced and mobile inexperienced. So we've got stuff to help you forklift from web into the mobile for the stuff you're missing. So I'm going to move into actually Q&A, and then we're doing giveaway time. I got the slides, I just realized, in the wrong order. So this is your time to ask questions. We have a few that have been asked. So Jeff, I will ask them and then either steer it to you or me, depending on who gets the answer. So there's a question: do we support Salesforce, DevOps, CI/CD? And I actually don't know whether you guys do or not. If you have a ability to comment on that. Salesforce, DevOps, CI/CD.
It's a good question. I don't know, maybe Robert can chime in, but generally, I mean, we have plugins into most of the major CI/CD pipelines, but we don't support force.com. So that's just a language we just don't currently support. But
yeah,
generally the integration into CI/CD pipelines is easy because the analysis is happening continuously, and so that at the appropriate point in your CI/CD pipeline, you can send a request to the Contrast team server and say, hey, is this application, did it discover any new critical vulnerabilities during this run? And you can get an answer back, yes or no, and then you can decide whether to progress to delivery and deployment.
So the next question is around, does NowSecure test the 52 points from NIAP as a default? The answer is yes. So the NIAP specification version 1.2 has 52 points of test coverage. Those are built into the platform. They run in an automated fashion, and then you work through the attestation to an interactive interface. You can then save default attestation approvals, which gets you into the DevSecOps flying wheel. And we have a number of federal organizations using it as a way to accelerate their DevOps pipelines and get to ATO faster. We also generate the reports in a format that are easy to consume to get through the paperwork on the back end there. Next one is, what's the best way to get started with instrumentation and observability? Jeff, you want to take that one?
Yeah, so there's a couple ways you can get started depending on your level of interest. So one easy way to do it is Contrast has a community edition. It's free and full strength for one application for anybody. So it's an easy way to get started. You can create an account, get an agent, add it to your application, and see the benefits of both IAST and RASP and instrumentation-based software composition analysis. So that's one fast way of getting started if you're interested. I also have an open source project called JOT. It's the Java Observability Toolkit, and it allows you to create your own instrumentation. It comes with a bunch of pre-built JOTs that you can add to your application, but you can also create your own very easily in a simple YAML format. And you can see the power of instrumentation and how easy and straightforward it is to measure your applications as they're running. So that's another way you can get started. Or of course, if you're more interested, we'd be happy to sit down with you and talk with you about how you want to go forward building a autonomous observability security program.
All righty, let me look at the questions. Actually, there's one that's asking about language support. So people are thinking about if I'm inserting something in my code, what languages work. So I'll answer first, you can answer second. Because the way we inject our code into the binary, we can test anything. So it doesn't matter what you wrote in, as long as your mobile app can compile down and run on a real iOS and Android device, we can test it, which makes us language agnostic for testing the code you wrote in any tool, as well as the code that, some third parties in there. And yes, we can test, these RAD, I'm an old guy, so I still call them RAD, server codeless minimum coding environments, the App Annies and those guys of the world. Because again, of the approach of the way we do it, it's language agnostic, so it can run at any time. Jeff, anything on languages in your world? Yeah,
it's really important. Java or Contrast supports a pretty broad set of languages. Most of the applications that people write are going to be in Java, .NET, .NET Core, Node.js, Ruby, Python, or Go. That's the languages or the language platforms that we support. Of course, that's multiple languages, things like C# and ASP.NET and so on, they all compile to something that we support. But I encourage you to dig a little bit deeper than just language coverage. On the server side, covering the frameworks is actually really important. They all work differently. Things like Spring and Struts and other application frameworks. Your tools have to know how those frameworks work. So I encourage you to ask, when you're thinking about buying security automation, think about the framework support that they have. And we put a ton of work into that. So we support a really broad range of frameworks. You can check it out on our website. We're very open about exactly what we cover.
Mm-hmm. And our content will enumerate all of our integrations as well, as mentioned earlier. So we have just a few seconds left here, a few minutes left. We're going to shift into giveaway mode, which is kind of a tradition we started last year. So I'm going to ask questions, and the first 3 people who answer the first question correctly are going to get a prize box full of swag and fun things. And then I'm going to ask another question, and the first 3 people who answer are going to get $50 gift cards. So I'll ask the questions. Be ready to type into your chat. And Kelly on our team will be monitoring and picking out the 3 winners for each question. Now, Jeff and I have kind of been around for a while, and originally we were thinking we'd ask a question about the birth of OWASP or something else. Is kind of an arcane piece of history. I should ask who helped write the original OWASP spec. Jeff. He's here with us today. But instead of that, we're actually going to ask a story about a story. So there's a very famous sort of DevOps journey book that was written by a guy named Gene Kim. And it has to do with rebirthing an IT infrastructure and moving it from a traditional to a new world. So what's the name of Gene Kim's and Community's first book? It's your first question. There we go. Looks like we have a couple of winners already in the Gene Kim fandom. If you have not read the Phoenix Project or the Unicorn Project, we suggest, collectively, those are highly useful along with all the other great content on both of our websites. So that's our first 3 giveaways. Okay. And I'm going to ask a second question, which actually is a little more on the mobile centric side of the house. And that one is, what is the best reference guide to figure out how to build your mobile testing program? It was mentioned today. It's 5 letters. What's the best way to build your mobile testing program? There's a document from OWASP. What is that called? And that will get you, it's not OWASP, it's the doc they created for mobile that I mentioned earlier. We're interested to see if you guys picked up on that or you're already using it. So I see 1 or 2 coming through. Feel free to throw 1 or 2 more. So that'll be our second giveaway as well. So Jeff, any closing words for our crowd here?
No, thank you, everybody. I hope we helped you understand a little bit more about how security instrumentation is revolutionizing the security testing world. It was a pleasure to chat with you, Brian. And please, everybody, reach out to me, connect on LinkedIn or Twitter at Planet Level. I love talking AppSec.
Yeah, Jeff and I are wide open. We're on Twitter. I realized I could have put our Twitters in LinkedIn. It's not hard to find us. I'm Read on the Run. So please connect with us. We love living the journey. We love sharing best practices and getting your feedback. As we said earlier, everyone will get a copy of today's presentation and the recording. That'll come out early next week. For those of you who were prize winners, follow up with Kelly will be following up with you to make sure we get your addresses and ship you the fun stuff and the money. And go spend it wisely and wear it well. Again, this is the first in our series of DevSecOps bunch webinars next month. We'll be joined by ThreadFix talking about vuln management and how to accelerate that through the pipeline. You know, a lot of what Jeff and I talked about today was more efficient testing. Well, what happens with all that instrumentation data that gets generated? Well, vuln management can help you figure out how to move it up and down through the pipe and route it effectively in very complex teams. And so we thank you again very much on behalf of Contrast and NowSecure and Jeff and myself. We wish you a great week and good luck here in 2021.
Stay safe, everybody.